Hello, this is February 9th, Friday class, and we've been doing the integer and basically two's complement numbers, how that works out. And before we continue on, I'm going to interrupt the discussion and talk about sort of an independent topic, which is homework 3. Okay? So it may work out really well. So we can continue on with the remainder of the integer topics on Monday. And I will go over homework 3. Now the homework 3 is quite different. And I think you probably need to read the homework assignment at least a couple of times to see the overall idea of what is going on. And let me start with that one. Okay, so I'm sharing the desktop. Okay. Okay, so sorry. Okay. So here, again, it's slightly different from what I think that you've been working mostly, and we can sort of think of function, right? So you have a function, which is a black box. Oops. And in the black box, if you have some function, then if you supply the input, then it produces output right away. A good example is the getting the character type in homework 2. So if you give a character the query character, then it searches the table and then return you the type, right? So each input behaves independent of any other input, and likewise the outputs are dependent solely on the current input or the input given at the time of the invocation of the function. In some of the situations, however, there are the different ways that the system or machine or this black box behaves. Okay. So one example. One example is the example I usually give. So you have a long corridor, the hallway, and you have an entrance in either end, and you have a lamp light in the middle. Okay. So if you have a light switch in both ends of the hallway, so if both light switches are down initially, and if I walk in and turn up the light, then light goes on, right? Goes on. And if I walk all the way across and turn on the light switch, then it goes off. So if this lamp is controlled by the switch, then if it's up, it's on, it's down, it's off. But when both lights are up, it may go off. So there is no the simple relationship to this one. And if you are a astute observer of the scenario situation, then you notice that this is an exclusive for logic. So when the both are down, it's off. Right there. Both are up, it's off. If either one is on, up, then it is on, right? So that's the sort of the scenario. So if you take a look at this behavior of the system, the simple scenario, then simple input of turning the switch up or down is not going to determine what happens to the light. It also depends on what was the switch location position in the other switch when you determine what the outcome will be or output will be when you take a certain action, putting the switch up or down in the other switch. So this type of system is called a state let me get you the different name. Okay. So this kind of function is what is it? Yeah, it is a function, right? So the output is independent of what the previous output was. So this is a memoryless system. Memoryless system. So outcome will be purely depend upon the current input that you're providing. It's not affected by what the machine was like before. However, this will be a memory based on memory full system. And if I draw it this way, this will give you some idea what's going on. Okay. So this black box or system will produce an output, and that is going to be dependent upon not only input, but another box, which is sort of hidden. So this is called a state. State. So when you supply an input, it not only affects how the function behaves, but also may change the state of the system over. So this is what you have in the black box, right? Black box. Depending on what the state was, the kind of output may be different, although you have the same input. Yeah. And this type of system is in a very fancy word called automata. Automata. And as the name implies, it's the automation, the auto machine. So it sort of behaves on its own. To be more specific, it's called a finite state automata. It's called a finite state because the kind of different states, the different status of the machine cannot be the innumerable, cannot be infinite. It has to be limited to a certain number. So that's what we are going to look at. Now, how is it related to homework 3? In homework 3, if you have let's say, let's say loop, right? So this is the possible input string that you used in homework 2, load word, $T3. And I just simple instruction, something like that. So the syntactically may not make sense or not. In homework 2, what you were asked to do was to look at the character type. This is 4, and skipping blanks. This 2, 2. This 4. Oh, this 3, right? No, 4. 2. 1, comma is type 4, and this type 2, type 5. Okay, so that's what you have. If you look at the input and output, if you have this input, what is this field called? Label, right? So label is supposed to have a name or variable separated by colon. And then you have the instruction or operation and dollar sign for the register name, followed by the register group and so forth. Okay. So if you take a look at this example and sort of look at how they are related to the character types, the types of characters, you notice that loop is a variable and they have the same data type. Colon is quite different from variable name, right? So it has different data type. And the operator instructions or the type 2 and 4 and 2, 1, this is sort of so the order is 2, 1. This belongs to a variable, right? So variable has to start with the alphabet followed by alphanumeric. And this type 1, sorry, type 1 for number, type 1. So what you notice is that if the character types are the same, they belong to the same group. Okay? And since their data character types are different, they are separate entities carrying different meanings. And this is the variable. So this must be a variable name, although it happens to be the register name, and so forth. So the homework 3 is now going to use this character type. Okay. And we'll look at it from left to right and check if the particular character belonging to this group can be coalesced into some logical unit. Okay. Or, for example, variable, name, and so forth. So that's what homework 3 is trying to do. So given this example, the first one is type 2. And now you need to compare with the next one. So if this is your character is O and type is 2, then now you have to look back and see what your immediate previous data type was. If it happens to be the same, then letter O must belong to the same group or same category as in the first letter L, which had the same data type. Look at the next one. Its immediate predecessor also had the same data type, so O must belong to the same group. Okay. And 2, same as the previous one, so they belong to the same group. Now hit on 4. Okay. Now the previous data, the character type was 2, now it's 4. So what do you have to do? Now you can break this one, and now you know that this has a specific purpose, specific meaning, and it belongs to one group for the variable name, in this case, label. Now colon is a type 4 different type, so this must be also a separate one. Okay. So in other words, when you determine to move on, go on, and keep collecting the character into the same group or not will be dependent upon what immediately preceding the character type was. In other words, the determination of the what kind of the output you're going to produce will be dependent upon what your immediate previous state was. The state in this case will be previous type. So you supply your current input and compare that with the previous type. If they are the same, you produce one output, which is to keep collecting, putting them into the same group. If your current character type is different from your previous type, then now you have to break it and start collecting a new character group. And each one of these is called a token. Token, this token, that is token, this is token, dollar is token, because there's you have type 6, character type 6, which is different. So this will be a new token. T3, starting with the character type, and after that, the alphanumeric is allowed. So this is one character type, one token. That comma is one token. This token and so forth. So you end up having these many tokens. So from this particular example, what you need to produce is all the collection of these tokens into a token table. Just two columns. So you collect the token. So in this example, the first token will be loop. And its token type is same as character type. Type 2. Next token will be colon, type 4, LW, type 2, and so forth. And in this assignment, there is a constraint that the token can be 8 bytes or less. So maximum token size is limited to 8 bytes. So we need 2 memory words to store one token value or token string, and 1 word, 4 bytes, to store the token type. So each entry in the token table, which the assignment calls a tap token, will have a 3-byte entry, and depending on how many tokens you have from a single input string, you'll have as many tokens you need. So this is the assignment. Now, when you write this program, let's say in C or Java, how would you go about doing it? And now it is different because you now have to keep track of what your immediately preceding the character type was, right? So I'll probably start with, let's say, when I start from the beginning, so that will be my previous type. So in this example, previous will be 2, character type, and that is given, right? And so no matter what, when you start initially, that should start the beginning of a new token. So the current token that I'm writing in capitals will be L. And now my character type is 2. Now I get look at the second letter, character O. So it returns returns a character type 2. I compare that with the previous one. Since it is same, now I have to add it to the token, letter O. At the same time, this will be now my previous, right? So if you look at the third one, that's a letter O. So the current character type of letter O is still 2. Compared with the previous, that's the same. So I'm going to add it to the next, the token character. And also the prev will be set to current. Okay, so that's what you have. Look at the next one, letter P. So character type is 2, compared with the prev, which is also 2. So I need to add it as a another character in the token. And also, I want to save it as the previous character type before I look at the next one. So the next one is type 4. It's different from previous character type. So at this point, I need to save this into the first entry in the token table. Yeah. So once I copy it out to the token table with the character type 2, which is this one, right? Actually, it's this one, right? The first one. Then I now saved or took care of this first token with this specific character string. And now I'm starting over again. So this is the beginning of the new token. So I need to save that into as a new token that I'm collecting. And this will be my previous, and current will be 6, right? 6. So now I have different character types. So I need to copy that over, save that into token table and type 2. And if I have a 6, then I'm just going to skip, right? Skip until I hit non-6. So that next one will be 2, type 2, and next one will be 2, since they're the same. Collecting them, but next one is 6, different, so that moves into the token table and it's okay. So this variable prev is going to keep track of my state. It could be, so my state can be the previous one can be type 2, 4, and so if this is the overall idea of what the assignment is about, then you can think of few ways of doing it. Okay. But I think that probably the simplest way of doing it is to start out with the prev of 0 or whatever, right? That's initialization. I'm not gonna do semicolon. Okay. And the current type will be, I don't know whether let's use next, right? So now the new, yeah. So new character type will be whatever I get from search function, right? Search function with the current character. And now I'm going to break up here. So when prev is equal to new, then what do? I add or concatenate, right? Concatenate the current it's just yeah, ch yeah. Concatenate that to my temporary variable where I collect only the new token that I'm collecting and collect one character at a time. So that's the capital token to token. Otherwise, if a previous one and think, do I want to initialize to 0? Maybe something else? Well, I'm not gonna worry about it now. Okay. Otherwise, now the new character type is different from the previous character type. So what do I have to do? Then I have to copy token token into the token table, tap token in a new entry. So that entry index should be incremented. And after I copied over, I need to clean or clear this temporary storage variable token. And now save the CHR. I don't know why I use that to token as a new token, beginning of new token, and go in a loop. And after I'm all done with that, I need to reset prev to the whatever my current one is, and going back to the loop. Get a next character type, see if the same as previous one, and so this is the sort of a basic idea. So writing this in MIPS is not really very complicated logic. The operation will be somewhat not simple when you copy token into token table and so forth, but the overall the control flow is not that complicated. So it can be done by writing an algorithm for this, and then converting into pseudo C and writing MIPS. That's fine. But in the assignment, you have to do it in a different way. And that has to do with the concept of a state. So what is a state? State is the one that, if you look back on this, state is the one that you are at. In this example, previous character type. And it's not going to do anything until new input comes in. When a new input comes in, it triggers the copy of that to affect what kind of output it's going to have. So as long as there are no new input, the machine or black box will not change at all, just like the regular function is. And just like the lamp in a corridor is, the hallway is, until someone triggers action by either pulling the switch up or down, nothing will change. Okay? So that's what it is. So that is the concept of state. And we are going to use that idea in the following sense. Okay. So the kind of a state that we're going to look at here is, let's use the same example. It's not going to be exactly the same as what you have in the assignment, but just to give you an idea. So let's take the same example again. So loop, colon, and whatever instruction we have, $T1, 4, something like that. So what is this state machine or automata has to do? It has to do first, in this state, nothing happens. But if you provide the first character, then you have to get its type of the first character, just the CH. And if the character type is 2 in this example, then this becomes a prev, right? Prev also. Say prev. Then you're going to take a certain action. So if a type is Get type is brief. Let's say it is T, capital T. So if a T is equal to 2, now this is the first time around, right? So what do you have to do? You have to now save the character in the temporary token collection variable token, right? This is for the first time. And after that, what do you have to do? Now I saved L into the token variable. What do I have to do? I have to get the next type, character type. T is the get type. CH again. Okay. Now if a T becomes 2 again, okay. 2 again, let me put them in a rectangle box. If the return type is 2 again, then what do I have to do? I have to go back, do the same thing, right? Save the character, which happens to be O, get the next type. If get the next one, still O type, same type 2, save that there, or the collect them into token, concatenate into token. P, the same thing. Okay. And now if next one is colon, save that into 1, and you got the next character type, which is 4. Yeah. So if it is type 4, type is 4, then now what do you have to do? You have to do something else, right? That's what is here. The type is 4. Copy token to token table, tap token, clear token, save that, and it's for that all has to be done there. And after that, you still need to get the next type. So you need to look at the next character, which is a blank type 6. Now it's different, so you're going to transition into different parts. So the idea of this state diagram, or the finite automata, is that if you're in a state, as you enter state, you perform whatever function or operation that's associated with it, and just stuck there until you have a new input. Okay, if you have a new input, then you do go somewhere to do different things, or if you it can be a repeat or in a circle. So let's take a look at the state diagram of this homework 3. Call the scanner, scanning from left to right and collecting tokens. Now the token type is same as the character type that you use in the homework 2, right? And here you don't have a token type 6 because blank is kind of the removed, and you're only collecting the tokens. So you still have the same types as in the characters. So if this is the example, then this is the token table that you have to produce. And after you produce this token table for this input string, you need to print this token table and clear the token table and get the next input. And according to the input, produce the token table based on the new input string, print it, clear it, and go in that infinite loop until you have the pound in the first character of an input string. So the idea is still the same. Okay, so how are we going to do the programming? So we're going to do the programming according to this state diagram. Yeah, you will be surprised for its complexity, but it's not the it's not really as complicated as it first looks. So you always start from the initial state Q0. So when you read in a new input string, and then you want to produce the token table, then you initially start from the state Q0, what you call Q0. So when you enter Q0, you have to perform this operation called A1, and A1 is the next character from the input buffer in buff, and that's your current character, right? And get the character type. And the variable t is used as the type. So after the first character, you get its type. And once you get a type, you always go to Q1. And once you get the character type, you go to Q1 to perform Act 2, A2. So what does Act 2 do? You save the current character as the first character of your token because you haven't seen it. Now the talk space set to 7, and this is to keep track of how many characters you have in the variable token because you are limited to 8 characters. So if the talk space becomes 0, right? Then you ran out of space, so you have exceeded the limit of 8 characters, you have an error, right? But you don't have to worry about, or you always make sure that your tokens are length errorless. Right? So you do that, and after you save the first character in the token, right? And if the type is 2, which is determined in Act 1, then you follow this path. It's an alphabet. So you now enter Q5, then you perform Act 1 again, which is to get the next character type. If type is 2, 1 or 2, then go to Q8, perform Act 3, which is to concatenate the current character into the top token, the variable. Reduce the space by 1 for error checking, but you don't have to worry about the errors. After you're done, you go back to Act 1, get the next character, get its type, still 2, keep going through this cycle, you keep collecting the alphabets or alphanumeric into the token or variable name. As soon as it is not of type 2, then you go to Q9 and perform Act 4, which is to copy token into token table, and it's the token type, right? Character type, which is token type, and clear the token, and token space reset to 8, right? And now you go to Q1, which is to store the current character as a new beginning of the new token. And this is not type 2, right? So if it's type 4, for example, you come follow this path, operator delimiter. So you perform Act 4, copy that over to token table, and then go back and start over again. Okay. If it's, so this looks somewhat complicated, but if you use the example that we had, I minimize, right? So if you use any example, put it side by side and see what kind of path they're going to take for this example. So loop, we kind of went through these. Now you have a colon, so you come out here, and Then you save that into the token variable and go back, C. Oh yeah, and then the save that to the token table and start over again, right? And get the next character. So if you get a next character, that'll be space or blank. And the current character is a blank, but since it's type 6 blank, you just go back, right, and get the next character. And if you run into L, then it'll be type 2. So save that to temporary variable token. And after that, you transition into Q5 and keep collecting that, and then so forth. So this part of the state transitions will handle the alphanumeric or variable name, and this one will be the digits, collecting digits. You need to collect digits, right? So it can be multiple digits. And as soon as they are not digit or not variable alphabet, then you save that into Act 2, right? Oh, you already did it. Copy that into token table, tab token. So yeah, you start over again here and move on. So this part is space for type 3 or 4, type 5, the end of the line, then you need to return, return from this whole thing because you hit the end of the string. Now, this algorithm will be a lot simpler, and this looks awfully complicated. But it turns out that it has a few benefits over programming in our typical approach. And first of all, if you're going to program this one, how are you going to do the programming of this diagram? The computer can never figure that one out, right? So what you have to do is translate that into a table, in a tabular form. So in the table, we're going to have all the different states, the place of this diagram. And the first one will be, first column will store what kind of action operation you have to do when you enter the state. So once you transition into this state, the first order of business is to call this function and do it. And after you're done, according to the character type T, you're going to change to different state. So in Q5, I have that. No, in Q4, where's Q4? That's interact. I think the numbers are different. 0, 1, 2, 3. Oh, it should be Q5. Yeah. Oh, no, that's correct, right? So if in Q2, if it is type 2, then you transition to Q5. Type 1, you change to Q2, right? So in Q1, if type is equal to 1, then you change to Q2. Type is 2, change to Q5. And if it's type 3 or 4, then you go to Q3, 5, Q4. Yeah. And if it's, you don't have 6, right? So type 6. Character type 6, right? Then you go to, from here, Q0, start over again. And Q7, type 7 is an illegal character. And again, I don't think you need to spend time on this, but it should be included for the future, the error checking. Q11, which will be written as 10, but yeah, error state. And in an error state, the error function, the operation you're going to do is simply print out that you have an error. You don't even have to identify what kind of error it is. And probably the best strategy is after that, you go to the end of the loop. So you exit out, break out, and clear things up, and then start over again. Okay. So if you run into any kind of error in an input string, just flush things out and then start over again. That is the idea, but since you make sure that all the input characters are correct, 8 or less fewer characters, and it's for, I don't think you'll hit on error state at all. So this is the one that you need to program. So idea is this table is, you start from Q0. So you start by calling act1. Act1 is getting the character type. So if it's type 2, then you go to Q1, call act2. And since type 2, go to Q5, perform act1. As type 2, then go to whichever state that leads to, and so forth. So you're stepping through this state table on the basis of which row you are at, right? And what is your current input is, which is the character type. Okay. So this is what you have. Okay, so you can sort of follow through some of the paths with specific the input string in mind, and you should have a pretty good idea. So the question has to do with how are you going to do star programming on this one, right? Okay. I think it's my this one. Yeah, this is the homework 2. So you get line and get the character type by calling, what is the name of search function, right? This is what you have. I didn't have that removing type 6. Anyways, that's the program I have. And in order to do it, I have to write a search function. And at the end, I had this tab char, right? Yeah. So since we're going to use the the character type search function, let me change this name to, can I leave it? Yeah, I can leave it like that. Okay, so that's what you have. Now this whole program is not going to be used in homework 3, but I'm going to use this search function. That's what I need. So here, as a new data, what I need is the temporary storage variable token, which is to request maximum of 2 bytes, two words, right? So word 0, 0. 2 words because 8 characters, limit to 8 characters. And what other variables would I need? By looking at this one, see, look at this one. Yeah, I need to have variable t. Okay, so I have a overall algorithm here. So you have I need to get an input string. Current state will be set to, you already start with the Q0 state. And character type, this can be anything. So set to 1. And I access this table. The row is determined by which state I am. So this is the row or state, the name. And then the character type T is initialized to 0, but since this starts with the column 0, 1, 2, 3, 4, so I'm going to look at column 0 or the second index 0 and find out what function it is. And once I get the name of the function or act, I call that function. And whatever my current type is, I'll make a transition or switch to that row or that state, right? So that's what we're going to do. Okay, so we need to use this getLine function, which we have. And then in order to step through this state table, I need to have that in the program. So I'm going to need in the data segment state table, which is provided here. Here, tab state, okay, tab state. So all I have to do is copy it out and put it into program. There, what is that extra line? So if you want, you can delete, remove all those excess lines. I'm going to do just a few. Yeah, where'd it go? Q2, Q1, and then support. So all the table is here. So all you have to do is copy. So I have a tab state. So I need to have a token, and also I need to have a token table, right? So tab token. And each token table entry has 3 words. 3 words, 2 words for the token and the type. So that's 3 words for each entry. So I think probably 10 entries, or you are not going to have more than 10 tokens from a single input string. So I can have 10 entries, 3 words each. So altogether 30 words. I can reserve 30 words of space, initialize with the 0. So that'll be 30 words. So this is the tab token space. Okay, so probably better to have 10 rows of 3-word entry. I think that's all I need for now. Okay, do that. So where is the algorithm? Is that? here. Okay, so the first thing is to call getLine as I did. Then I'll get the input string in the inbuff. And next thing I need to do is initialize state to Q0. And I specifically ask you to use S0 for T, S1 for current state. Okay. So the first thing I have to do is, oh, actually, you know what? Yeah. I don't need this anymore. Branch to next line. So this is an infinite loop. First thing I have to do is put the Q0 state into S1 register. So that's S1 has current, right? So I need to put a address of the current CUR, no, Q0, right? Q0 into S1. And I need to initialize T, which is in S0 to 1, or in fact, any value in S1. Oops. To can initialize to 0 because the first thing I do is get a character type. So this S0 will be updated right away. And find out what the name of act function is that I need to call. And the name of the act function, where can I find it? Let me start new. So this is my state table. Tab state. And this is organized in this way, right? Q0, Q1, Q2, and S4. Let me draw it in the actual data form this way, right? Okay, great. So that may be clear. So the tab state starts out with the Q0, and so this is the row or index into this row. And the first entry in this row of Q0 is on act1, right? Act1. Oh, sorry. Dot word act1. And the second entry is, I'm gonna go back and one Q or the Q1, Q11. Okay. So the word of Q1, and that's fourth. And state Q1, the first word you will have is the act2, right? 2. And then the series of different states, Q2, Q5, and yeah. So if you have a label Q0 with the offset 0, so this word or first, the next state that you have in this table entry or in this row will be at Q0 plus 4. Next one will be Q0 plus 8, and it's 4, right? So Q0 will have the name of function you need to call. So you need to bring that into some some variable. So at the column 0, or the where your current state points to, is going to be brought into name act. So we can use a variable. Let's say which, I think I used the S2, right? Yeah, S2. So I'm gonna get the name of the function into register S2. And what I can do is, since address Q0 is already in S1, I can dereference it into S2, where S1 points to. So, oops, S2. So this will be my act. Name of the action. Now, since I have the name of the action, what I have to do, I have to call that function. Yeah, act 1, 2, 3, and S4. For that, I can do jump JAL, jump and link. But for jump and link, I have to have the name of the function as part of the instruction, but I don't have that. That is in a register, not in the instruction itself. So if I have the target address or name of the function in a register, then I have to use JLR register. So that will be going by S2 register. And in the first operand, I have to give the return address, what register I'm going to use for the return address. And what do I use? I think I can use any register I want. Okay, so I need to use, in this example, I use the V1. Let's use V1. So this is same as jump and link, except that function name is in there. And now I stipulate that after I call this function, return address should be saved in the V1 register. I could use array register. That's not a problem at all. Okay. So after that, yep, not this one. I call the function. What do I have to do? I have to get the next day, right? According to the value of the t. So if you look at the table structure, if t is equal to 1, then next state is q1. T is equal to 2 at address q0 plus 8 and S4. So if I get a value t in S1 register, now I have to multiply that by 4 because the C index, right? So I think I can use a different, let's use different register, T0 and S0 has T, S0 by 2. So this one will set T0 equal to 4 times index the character type T in S0, right? S0. I can remove the dollar for it because it's too cumbersome. Once I do that, I can now add it. I don't want to use different register to confuse it. So S1, oh yeah, I need to, oops, add T0, which is the byte offset from whatever state you are in. And state I'm in is an S1. So I need to now add S1 and S0 T0 because multiply by 4 byte offset. And once I have it, now my new state will be in S1, right? So I can, new state is S1, so I can go back to 3, which is getting a new act, right? So that will be here. So this, I can branch to getting a new state. Going to the new state and starting off new row and starting off with the new act function and as forth. So this is the next state. And next state will be here. Okay, keep going. Now, if you have an action, the act, which is which is a return function, then I'm going to get out of this stepping through the state table. So that will be your, thank you, stop. This is where I print tab state token and clear in buff, clear token, and clear tab token. And after I clear everything, I need to go back to, sorry, what am I doing? This should be after I'm done here. So as I step through, if I hit on return action, then that'll bring me out of that loop. Then print tab token and clear everything and go back to the new line, next line. So get a new input string and then go through this sorting. Okay, so this is the program you need to do. And all you have to do is the only set of programs or functions you need to write is you have a search function already. So this will be your act 1 actually, right? So act 1. And you need to write act 2, get line is there, act 2. And when you're done with the action, the return address is in V1, right? So this is not RA, you need to return by way of V1. Act 2, the same thing, ends with V2. Act 3, I think you have 4x, right? Actually, I V1. Yeah, you only have 4x. Four X functions and return. Did I use RET or return? Return. Oh. Return and error, right? So that you need to have that. Error. And error function, you print out an error message and then you clear everything out, or you can, I think, you print whatever you had collected so far in the tab, clean everything and start over. So you can go to print an error message and branch to dump. And when you want to return from this sort of infinite loop, then you know get out by going to dump. So the return, where is it? Yeah, return function will be also branch to dump. Yes. So all you have to do is basically writing these 4 or 5 functions, because you already wrote the search function. But the stipulation here is that after you're done with the search, character type should be in S0 register, T0 in S0. So let me check. Return should be A0, no, it should be S0, right? S0. So I need to change that to S0. I'm using S0 for another purpose. So maybe I can use T in that. How about A0? A0. I got mixed up. So this is the S0 that I have to return character type from the tab chart. What am I doing here? So maybe I should use different register. So character type is initialized to -1. In case you don't find it, load the address. Get the first character in A0. So this is to examine each character, right? So let's do T1, not to be confused. And see if T1 is the end of the table, tab chart. Equal, then you quit. Otherwise, the search key is in A0, and now your table key is in T1. They are the same, then you found. So yeah, return. If they're not equal, then you increment T9 index. You don't use T0, right? So why do I have that? Oh, I'm adding it, right? So keep adding to T9. So I think that's okay. But I don't use T0 anyways. Commented. So you have to make some adjustment, but that'll be your Act 1. So you can change the comments as well. Yeah. So homework 3 is due a week from Monday, which is a holiday, but doesn't really matter, right? So Monday 20th, and you have test on Wednesday 22nd. And doing this homework will also help you getting things clearer for the test. So don't consider this as a sort of the double work you have to do, preparing for the test and doing the homework. Okay, I went over a bit, but so sort of, and also that's why I'm sort of glad that I did it in recording, because I can do it without interruption. Okay. So take a look at the assignment and have a good grasp of what are the operations that are involved, or what are the overall assignment is about. So you can look back on this example. Okay. Normally you do start doing programming this way, but I want you to use a totally different approach using state diagrams and then using the functions, just stepping through different states. Okay, so you may have noticed or experienced that these homeworks require some time to complete, right? Because again, you're dealing with the new syntax and new way of thinking, because you have to not think like a machine. So it takes a bit of time. So I strongly urge you to start early. So as soon as this weekend, and start asking me questions. Okay, have a good weekend. And when you come back on Wednesday, I'll sort of go over this in a different perspective and resume with the integer discussions on integers. Okay, so have a good day. I need to stop.